mentioned in the Git repo. It is actually free one, and for that you don't have to pay any money. Yeah. So today we will cover storage, mainly storage actually. So yesterday we looked into pods, deployments, and then services. Any questions there?
No, second.
Yeah. So, share entire screen.
Saruna, I think you should probably start with a couple of questions. Just check whether they are answering. Otherwise, they'll be out of track. At least some fundamental questions. Check anyone is able to answer.
Yeah, sure. So, Ganesh, what's your understanding about pod? Just give a brief, whatever you understand.
For today's class, right?
Yes.
Yeah, the Kubernetes like normally it's a collection of control and the control plane and nodes, right?
Yes. Yes.
So in control, like normally we have kubectl. In control plane, we have like normally so this etcd and this is a database and scheduler and API server and control manager. So we are this is a kubectl is a command tool, like we are communicating with this API server, and this API server will communicate everything with the control manager and scheduler and this etcd. And in worker node is normal like a server that we want to work every application in that worker node. In that we have pod. In that pod, like we have running containers, right?
Yes. In the pod we run the containers. So
yeah.
pod is
in container like normally in container runtime there's a pod, and in pod we have container, right?
See,
yeah.
For running containers, you need a service to be up and running. That is called container runtime. The container runtime provides a service which enables to run the containers.
Yeah, that is start and stop like that, right?
Yes. So you have to actually first start the container runtime, which is Docker D. After starting the the container runtime, you can actually start the containers. Container is nothing but application, right? With respect to Kubernetes, you package the container as pod, POD pod. Okay, in a pod, you can have single or multiple containers present. So that is, I think, one of the example I gave, right? So you are actually running on application in a container, and in another container, you are actually going to log something, log the details. So you can actually put together both the containers in a single pod. So, okay, what is a deployment as you guys understood?
So creating replica sets for the pods.
Yes. So, so in addition, like, you see, a deployment is the complete application, along with the replica. You can have service as well mentioned in the deployment. You can have storage as well mentioned in the deployment. Usually in the deployment file, you have all the things present. Like there are some secrets, passwords, some environment variables. All the different information can be mentioned in the deployment. So deployment is the a core way to deploy application. Normally people don't deploy pod alone. It doesn't make sense. You need to really expose it to the outside world, right? So you need to create a service now. So all put together becomes a deployment. So, and then we started looking into the service. Let's continue that part. Okay. Any questions?
Yeah, Sharvana. Like, what is this desired state and current state?
So basically, desired state is like in a deployment, we say I need 3 containers, right? Okay. So I say replica 3.
Sorry.
So that is my. I say replica 3 in a deployment.
Okay.
Means it is actually creating 3 containers, right?
Okay.
Yesterday I have shown you, right? I created a deployment. In that I have mentioned 3 replicas. It is in turn creating 3 containers, correct?
Okay.
Do you remember that?
Yeah, got it. Yeah, you give normally three replicas to be run like that in you normally mentioned. Yeah.
Correct. So that is the desired state. So what happens, whether the system is able to create the 3 containers or not is the desired state. Sometimes what happens, due to some issues, it won't be able to create the containers, right? So at that time it will tell the desired state is 3, but I can only run 2, right? So that is the difference between desired state and the actual running state. Got it?
Got it. Yeah, thank you.
Yeah. So we'll start with the service. A service is an abstraction that defines the logical set of pods that provide stable networking, enable reliable communication between the pods. I think we discussed it yesterday, but just to recap as well as to continue. So you need a service. See, you create a pod, you have application, you containerize it, you have written a Docker file, and then you create an image out of it. You are running the container as a pod, right? So now the pod is running. You have the application running. Or you need a service on top of that. So the idea is you may have 3 pods. One of the pod may go down. Okay, you may have only 2 pods. Now, all the different pods, all the 3 pods will have different IP addresses. We want to create something on top of the pod which will be exposed to the outside world. Okay, the pods will come and go. The pods will die. The pods will crash. But the service is a stable communication endpoint, which is talking with the underlying pods. Got it? So it is actually an abstraction layer which is written on top of the pods. Why? Because the pods are quite unreliable. It may go down at any point of time. So we need a logical abstraction layer to which other applications or other users can talk. Got it? So what are the key features? It enables load balancing across pods. So there are 3 pods running on 3 different nodes. We want to actually balance out how the pods are getting used. Let's say we have a web server and some thousands of users are coming in and trying to access the service. So it will first hit the service. Okay, internally it will go to the some 10 pods are running. You consider, okay, 10 pods are running. So internally it will go to one of the pod, right? So the load balancing to which pod I should talk to will be taken care by the service. So you guys are following?
Yeah.
Okay, so now the service provides DNS resolution for the pods, allowing them to be accessed by the name rather than IP. So see, the IPs will be keep changing. You guys know, right? So the IP address is something a basic unit, in networking. So sometimes when you reboot a machine, you may get a new IP address every time. You guys are aware of this, right? So there is something called DHCP. Sometimes let's say you boot a machine, right? You get a specific IP address. Now you have shut down the machine. After a day, you are again switching on the machine. You may get a different IP address this time, right?
Yes.
This is a quite basic thing, like basic networking stuff. So by means of dynamically getting the IP address, we will be getting every time we may get a different IP address. It will try to get the same old IP address, but if it is not available, the system will get a new IP address. So something like a system, the pod will also get a different IP address every time it launches. So we cannot rely on the pod's IP address. So that's why we are actually going to make use of the service IP address. The service IP address is quite stable in nature. So that way the applications won't have any surprises, and I cannot reach this IP address. The IP address is taken by someone else. So that kind of problem won't come here. So also the DNS resolution is very important. So between the pods, like there are cases where you have pod 1 running in node 1, pod 2 running in node 2, and they want to communicate with each other. So to communicate with each other, we create a service on top, and then they talk to each other by means of the DNS name. The DNS name is nothing but, you type google.com. You can actually type IP address of the google.com as well, but you go and type the google.com because it is human readable. You don't have to really remember any numbers, right? So again, I will ask you guys to just have a grasp of what is DNS, how DNS works. It's very basic networking. So something similar to this, you say that you access a service by means of a DNS name, like FTP service device local, something like that. You can actually access. I will actually show in the demo. just remember that just like google.com, you can actually provide a service in a name, and using that name, you access that service. So also within the cluster, by means of exposing the service with a name, the service discovery happens. Like I am actually providing XYZ service, I am actually provide ABC service, like that. Actually, with this name, we will be able to identify. So and this way, actually, they exchange the services between the pods. So any questions till now? Actually, we will see an example to understand this better. Just have a basic overview of this. And then there are some different types of services. One is called cluster IP. Okay, this is actually used for internal communication. Like once you create the service, this is the default one. Even if you don't specify the service type, it will automatically create a cluster IP based service. This is for internal communication, like between pod to pod communication. Node port. Node port is you actually expose a service using the node IP and node port. What is node IP, node port? See, whichever node you are running that pod, okay, whichever node, whichever server you are running the pod, that IP address and that port will be used for accessing the service. So I'm just going back from the beginning. So you have a Docker file, you created a container image, you are running that container image in a pod. Now you are able to use the pod, okay? Now you want to expose it to the outside world, like at least within the LAN. Now you say like kubectl expose this pod. It will create a service. Now to access the service, you make use of the server IP and the server port. So I told, right? So every time you want to make use of any service, you have to use IP address and port number. So that is what we are trying to do here. There are different ways to do it. And node port is one way, like you make use of the server's IP address and server port. So we have seen two different types. One is cluster IP and node port. Let's go to the other ones. Another one is load balancer. Again, this is with the cloud native load balancer. Like, AWS means this is a little complex. Like you have to actually make use of the AWS load balancer to access the service. So what type of service when you create, you tell that it is a load balancer type. And then there is another one called external name. Again, there are two things, right? The external name is if your service wants to access some other service which is lying outside. Say for example, you have S3 service, right? S3 is a storage service provided by Amazon, right? So from your application, you want to access some service which is available outside. Then you actually go and create a service with this name. Now, once you create with the external name, you can actually communicate from the from the service inside the cluster to outside actually anywhere some XYZ is providing a service, we can actually make use of it. In this case, I'm telling about Amazon S3 service. So and then we have the headless IP, headless, and then which is actually like this is just to create a DNS record without a stable IP. Like normally, service will create IP, but in case of headless, we want to create a DNS record. Again, DNS is nothing but a naming. I will show the example to understand this better. So that kind of naming it will provide, and between the parts, we make use of this name to access the service. Say, for example, databases or any other services, we want to access directly the part. So that way, it will actually create a DNS record and make use of it. So just remember that there are different type of services: cluster IP, node port, load balancer, external name, headless. So load balancer is about incoming service request, whatever service that you are providing and it is used by someone outside, that is load balancer. External is someone is providing some service outside and your service is trying to talk to that service, that is external name. I think headless is as the name say, it is just a DNS record, and some internal direct access we can actually make use of headless. It will create DNS records for that. Yeah, that's pretty much about the different services. We will see examples. I think hearing different names, you guys, it may be a little difficult.
So with the
for you.
headless service, Sorry, can you please go back? Yeah, with the headless service. So if in node port service, we use node IP and the port, right? So here
Yes,
we don't
correct.
need to use that. We can directly, like how you mentioned, www.google.com. So some name we can use to access our containers. Is that right?
Yes, correct. That's right, actually. That's right. So the naming will be something like service name, which namespace it is, which cluster it is, like that the DNS record will be created. You are right.
Sure,
See,
sure. Thank you.
again, just to add something extra here, right? So node port is a basic one. See, in Kubernetes, we really don't want to rely on a specific server sort of thing, right? So node port is one simple example, to understand. What if the server itself is down? You will actually be, missing the service, correct? You guys are getting?
Right, yes.
Yeah. So then you should actually, in a production environment, you will be making use of the load balancer. So load balancer is again like, depending upon AWS, you need to create a load balancer in your AWS, and then you have to make use of that in your service. So whenever someone hits the AWS load balancer, they will end up, reaching out to your service. Yeah. So any other questions?
So all these services go hand in hand, isn't it? Like node port, load balancer, and like headless and load balancer, for example.
Uh, I'm not sure what you mean by hand in hand.
Like we need to have load balancer if we are creating a Kubernetes cluster, so that if we are working with heavy workload, and or maybe to connect to the Kubernetes cluster, like instead of node
Yes.
port, we can simply have load balancer.
Yes. You can simply have load balancer. Node port is very simple, right? To load balancer, you need to do some extra work. You need to do something in the AWS, and then only you know the name. You have to tie the service and this load balancer. So you, depending upon the usage scenario, see, if you are not at all going to expose your service, you don't need a load balancer and all, right? So within the Kubernetes cluster, you are exposing a service. You don't need load balancer and all. You can actually, you can make use of headless service itself, right?
Right.
Got it?
Yeah.
Yeah. So depending upon the usage scenario, you will be choosing one among them. So yeah. So we'll start seeing the demo. So I have actually created one. Let me see. Are you able to hear me?
Yes, sure.
Yes.
Yeah. Have you guys tried out setting up the cluster?
Yes, I did yesterday, but I was working on it. But before I could run some more things, the access key became invalid.
Okay.
Actually, I tried it running it. I tried installing it on my local system. But since I
Okay.
use WSL, I was trying to create the node port service. But and also trying to see how workload is distributed among the pods. But somehow the WSL seems to be broken or something. I was not able to install Hey or the Apache Bench. I tried both of them, but I could not install anything.
Apache Bench. Okay. I don't know what it is.
Just to
Sorry.
see how the workload is distributed
Okay.
among the pods. Like, is there any alternative without like installing them? I couldn't figure out till now. I should see more about it.
Actually, there are some example applications where you can see how the load is distributed. I will actually try to get and share with you.
Sure.
Right. So actually, it will tell that which pod is serving now. So you have 3 pods. You'll get some print statement saying that this is served by this pod, or part 1, part 2, part 3, something like that. Actually. So that is very useful. But normally, I mean, you need to really force it to, switch. If there is not much workload, it will not switch, right? So that is that. You need to force it to switch.
Yeah. That's what I was trying to install Hey, which is like HTTP request creator, and it will generate the HTTP requests and send it to the pods. But somehow Hey did not get installed in my WSL.
What do you mean by WSL?
It's Windows subsystem for Linux.
Okay. Yeah. See, actually, software world is really big. It's very difficult to try out many things. Like so.
Yeah, that's right.
So nowadays, it's very difficult for a single person to learn all the technology, especially in this Kubernetes. It's really going very fast. Also, changing also it's very fast. So I'm just wondering, like, whenever I actually download Docker and all, right? First time you run a command, it will work. Next time if you run, they say, it's absolute now. You need to it obsolete. It's you need to really change the command line arguments like that. So
Right, and there are lots of tools like Docker. Similar to Docker, you have lot many. I don't know like how we can keep track of all that.
yes. So I think, see, even for orchestration platform itself, right? There is something called Docker Swarm, but you don't have to. I have never gone through Docker Swarm. The thing is, not many people are making use of it, right? So we don't have to really spend time on that. Doesn't make any sense, right? How many things you can actually study and learn? At least to do one thing very thoroughly rather than touching on many things. Just tell that if you don't know, I don't know this technology, but I'm aware of the other one, and I know the basics and stuff clear. I will again repeat you guys, like, please make use of Linux system as much as possible. So unless you try out and get hands-on, it's very difficult, right? So if you just keep using Mac or Windows, if you are very serious about taking a career in DevOps, you should actually consider using a Linux system as much as possible. So you should see some issues. You should actually break things and fix things. That's how you learn. We are like we are very used to like, what do you say, like smoothly functioning, right?
The
So
GUI type of this one.
Yes. So okay, the node is the cluster is set up now. We have everything running. So let's actually set up a service. I have something. I have actually updated that commands file. You can actually check. Let me actually set up the deployment first. So I'm actually setting the so okay, my deployment is up and running. So you can see it has some labels, right? So the label is applied like app equal to my app. So the label thing is very useful. So I will tell you how. See, actually, when I create the service, I say the selector as app as my app, right? This is how actually you link a service and a deployment. Okay, so let us create the service as well. So I have created a service named my service. So I can see the service is set up. So actually here, I just want to explain about two things, right? So the type is node port. Okay, so it is actually making use of this port number. Okay. So, and there are the 3 endpoints. So what are these 3 endpoints means? The endpoints, actually the service is tied to the deployment. How? It is tied by means of the selector. Got it, right? So I will just show you that deployment.
So we have 3 pods. Is that why we have 3 endpoints?
Yes, correct. We have 3 pods. That's why we have 3 endpoints. Let's see a specific pod to see this IP is there. N.244, right? So see here. So actually we have a pod. Okay. So I just did a describe of that. I'm looking for this 10.244 IP address. Got it. So that IP address is here, right? So this one, correct? The service is tied to the pods, 3 pods. So this is how it actually distributes between the pods. But it is actually exposing it with a specific IP address and a specific port. But internally the endpoints are 3 pods. Clear? Okay. So not clear.
No, clear. It's
Yeah.
clear.
So this is how we reach it, right? So let's try to do a curl. Okay. So because I have not actually, in the service, I don't have any node port specified. I have not specified any port actually. So it has taken automatically it has taken a free one. So which is 32180. Okay. So let's try to reach out. So for this, let's get the IP address of the node. Right. So what is the IP address? The IP address of the node is 192.168.49.2. If you are running it on the bare metal machines, right? You have to actually go and check. You can actually check the IP address in your machine like that, like this also. Like you do IP address, you'll have an interface, right? Ethernet interface, right? That IP address you'll be making use of. In my case, like in this case, like I'm actually making use of a Minikube. The Minikube is set up using VM, again a virtual machine, which is making use of this IP address. So this IP address and this port, I should be able to access. Curl yes, reach out to 32180. Okay, so I'm just trying to see. I'm actually trying to access the Nginx server using this. Okay, let's see. Okay. You guys got it? So see, I'm actually able to access the service using the node IP address and the port where it is exposed. Okay, the node port. I can actually access the service, right? So can we do something like, can we actually try to access from inside the pod? Let's try it out, okay? So I'm going to actually run a simple tool image, which is VisiBox. I'm just giving it a name, Perl pod. I want to do it interactively with a terminal, just to try it out, okay? So this is, just to try it out like a pod-to-pod communication. I'm running a new pod and I'm going to test out something. Okay, now I'm running a new pod actually. So I'm inside the terminal of that. Let's try to actually access this. See, I can actually access it, right? So basically the service is provided like this. So every service created, it has this type of DNS record, like the service name, the namespace, and then the cluster name, SVC service. So something like this. So you're getting the point, right? So I created a new pod. From within the pod, I'm accessing the service. How I'm doing it, I'm actually getting into the pod. From the pod, I'm trying to make use of a DNS name, right? So this is a DNS name, right? So I can actually access the service. So we have seen a simple example of creating a deployment. The deployment has 3 pods. On top of that, I'm creating a service. When I create the service, it is going to make use of the node IP address and node port. Internally, it is actually going to the 3 parts which are created. So every time I access the node port and node IP address, I will internally access the application. Clear?
Yeah. Where is this new pod that we created? Where will that be? Is it a part of the previous structure, Kubernetes structure?
No. Basically, this is a test image. See, BusyBox is I told, right? So this is a tool image. You have multiple tools present in this. Okay, you want to communicate from within the pod. You want to communicate with the service. Okay,
oh, so here we did not create a new pod.
Okay, see, I will just I'll just show you that. Okay, K get pods. If I do a K run the same pod, curl pod, okay, I'm going to run an image as BusyBox. This time I will not say I want an interactive pod. Okay, I will not say you make use of the shell at the end. I'm going to skip all this. Maybe I'm going to skip all this. I'm just going to run the pod. See, it's completed, right? So what happens is it is actually running the BusyBox. Okay, it is running the image called BusyBox, but as such, it is not doing anything. It started, it completed. You are getting the point? But
yeah,
the main intention behind running this pod is to run some command and to access some service. Any confusion?
little bit. I'm so sorry.
See, okay. See,
so I'll no. Let me just tell. So
yeah,
you
please.
created a new pod which is called curl pod.
Yes.
The name of the pod is curl pod, and it is also a part of the same Kubernetes structure that we created yesterday. The ones that are already running here.
Yes. We are already running Kubernetes cluster, and in the cluster we have already some deployment services running.
Yes.
Okay. You can run multiple pods in this, right? So,
okay,
like as many pods you like, you can run, right? So,
yeah,
only thing is you have some memory and CPU resources. Give me a second. Someone is here. I just want to reach out. Sorry.